Hey, everybody, welcome back to the Doctors In podcast. I'm your host, Dr. Nadia Saba. Today is part of our Energy in CEA series, and my guest is Gretchen Schimelpfenig. If you attend Indoor AgCon, CE Ag World, or any of the Glaze webinars, you have probably seen her talk about energy and CEA, ask tough questions of panelists and speakers about energy, and lead the discussion around this topic that only now everyone seems to be talking about or paying attention to. She is currently a senior energy engineer at Energy Resources Integration, or ERI, where, amongst other things, she helps their customers and clients find energy incentives and rebates. Before she worked for ERI, you may have run into her working at Resource Integration Institute, or RII, and I think she was really integral in some of those early best management practice guides that RII was putting out. Um, although Gretchen didn't start in CEA, she is a fan and a true advocate for our industry. And one of the ways I think that she demonstrates that most is by co-founding Vivid Canopy, which is a network of professionals that really advocates for diversity and equity in hiring practices and in our jobs within the CEA industry. Gretchen, thank you for doing that and for launching that. Um, so yeah, I mean, I think that Gretchen and I could probably talk on many different topics, but I do think her specialty is energy. And Gretchen, I'm so excited to have you on. You've had your hand in so many of the topics that we've already discussed to date in this series. Everything from best management practices to energy codes and standards and incentives and modeling versus measuring. I'm really hoping, and no pressure, but I'm really hoping you can kind of help me bring home the message of why energy is so critical to the CEA industry.
Here's hoping.
So let's start with a simple question. There's no simple questions in these interviews. Why is energy such a hot topic today in CEA?
Well, I feel like in the years that I've been in the CEA industry, which is around like 8 or so, I've hoped that energy would be a hotter topic. But I guess I'm glad to see it's becoming a larger focus as different costs of doing business fluctuate. And so, energy being a key cost of doing business, leaders of this industry succeed by managing costs, maintaining better profit margins than their competition. And so I feel like energy is becoming a hotter topic because profit margins are getting thinner, other costs are getting tougher to manage. And so energy is now this cost that's on the chopping block that is maybe easier to manage than some of those other ones like production costs or labor costs. So that's one of the reasons why. I also think that energy is a hot topic because there's money on the table, and that money
Mm.
is first come, first serve. And so every year there's this sort of call, this ringing of the bell where the rebate programs are like, come and get this money. And there's grant applications perhaps at the state level or at the federal level where they're asking for folks to come and ask for that money. So there's money on the table. Hot topic when there's money on the table. You don't get money for every type of project, but you might get money for an energy project.
So necessity and opportunity, I guess, in a nutshell.
Yeah,
Can, can you kind of describe the relationship between energy and CEA? Like, why is energy so important to run a CEA operation? How is it used in CEA?
sure. The relationship between energy and CEA kind of has to do with the difference between agriculture and CEA. So
Mm.
agriculture has always used energy. We've got equipment like irrigation pumps, maybe on-farm vehicles, but controlled environment agriculture involves buildings, and buildings demand energy. So bringing plants inside creates a need for horticultural process systems like fans, ventilation, pumps for heating and cooling systems, lights for supplementing or replacing the sun. And so energy is actually what brought me to the CEA industry because of concerns that indoor farming of cannabis was creating a huge strain on electricity grids. And the media has written about energy hogs for years because of the high-powered lighting required for some crops like cannabis and tomatoes. I would just say the hard pill to swallow is that the controlled production of some crops creates energy challenges, and that's just going to happen. That's why energy conservation and energy efficiency are so vital. We've got energy costs that aren't consistent across the country. They're not even the same at this, state level. So a way to get an edge sometimes is to be located in a place with low energy costs, and energy costs are always going up. So I feel like the relationship between CEA is you've created a demand for energy with all these process systems, and now you've got to look at energy as a variable to change by perhaps being located optimally or having a plan for how you're going to make energy costs go down over time rather than up.
Yeah, I mean, when I just think about energy in general, energy is an input, right? That when we talk about controlled environment agriculture, it's the control piece that's the energetic piece of controlled environment agriculture, I guess. And so if we are going to control the climate or control irrigation or control lighting, then we have to put a force on it, right? And that force requires energy. And so, just by definition, it's an energetic agricultural process. And I don't think necessarily people make that connection. We talk a lot about energy balance also when it comes to HVAC, and plants are a great sink for solar energy and for heat energy and sort of the energy in our environment. And plants are great converters of solar energy into carbohydrates, right? Into food energy or whatever. And it's that process, I think, that we're trying to control with other sources of energy, right?
Yeah, absolutely. I think that there are some controlled environment facilities that might be able to minimize the controlled aspect and like really have systems that don't operate as much or don't need to operate as intensely. Perhaps they're located in a nice climate, right? Or one that gets a good
Yeah.
amount of natural sunlight, but not too much heat. But like that's not the case for most greenhouses, especially or indoor farms. If they're being located in a place that has good population density for the distribution they need to do, it might be in a cold place. It might
Mm,
be in a not so sunny place. So yeah, CEA is
yeah.
inherently an energetic activity.
Okay, so we know that CEA it converts energy, it uses energy to do that control that we want. Um, can you define for us what is meant by energy efficiency?
Yeah. Energy efficiency is usually a strategy used to reduce energy consumption or avoid using energy altogether. Like for greenhouses or indoor farms, it's going to be something like installing high performance equipment like LED lights, greenhouse curtains, high efficiency anything, right? Um, and that's why they call it high efficiency. It's better than something else on the shelf. And so
Mm,
energy efficiency strategies are just doing a choice that's slightly better than maybe codes or standards like you were talking about earlier.
yeah.
Um, and so it's a lever that businesses can pull to get better returns on the investment. It's usually going to involve spending capital, but it's supposed to have a good payback period and ultimately win out over a business as usual case. And so at its core, an energy efficiency activity, which is sometimes called like a measure, which usually might result in a rebate from a utility, should always result in energy savings. Either it's saving electricity, natural gas, some other fuel, and might have, associated emissions reductions, which might be something that a grower cares about or a business might want be able to, move towards a sustainability plan by doing energy efficiency.
Okay, so your response brings up two questions for me. One is I'm going to start, I think, with the Oh, I don't know which one is easier or harder. Okay, so you said that, like let's say we use some high efficiency gadget or component, and you can save energy by using it. And then you said, relative to something else. I want to stick on this for a second because I feel like this is one of the biggest challenges in CEA is figuring out what we're comparing to, right? And so I'd like you to talk about that a little bit about baselines, standards, and even like the work that RAI and others have done to try to figure out like what is the baseline energy use that these facilities are using, or what is a standard piece of equipment that we could replace with a more efficient equipment? Where are we in terms of making that comparison?
So I'll answer the first part of that question, which is like, how do we figure out the baseline case for each greenhouse or indoor farm efficiency project? Uh, in some cases, it's what they had before. In that case, it might be like a retrofit scenario where we might just be comparing to find out how much energy we're going to save if we replace 900 high pressure sodium lights with 1100 LEDs. Like, what's the savings there? But utilities, when they make rebate programs, often come up with an industry standard practice, which defines the baseline for a whole, sometimes like state. So often that
Mm.
depends on the energy code that the state has adopted, whether they've adopted anything related to CEA, and whether they're enforcing code at the county level. So I've even had situations where the state has a baseline for something, but at the county level, it wasn't enforced. So the baseline shouldn't really be the code. It should be the way the authority having jurisdiction enforced the code.
Oh my goodness.
Yeah, like it gets really smushy, right? But but to answer the second part of your question, like the baseline system types, like for things like lighting that we've been talking about, a lot of states and utilities have been actively trying to figure out what is the baseline for lighting. And so you and I, working in California, know that they've recently made a sort of hybrid baseline where LED has influenced the baseline a lot. And now the efficacy requirement for rebates has gotten quite high. Whereas in other states, there's really no bar for baseline. And
Mm.
so any efficient light can kind of get a good rebate. So how do we define that? Sometimes it's through things like surveys, interviews, site visits, utility studies that are funded that are multiple years long, like I'll talk about later. So it's like a research project. And sometimes these research projects are done over and over again in every state because they have to come up with an industry standard practice baseline for every state and every utility territory. So it's what keeps engineers like me busy sometimes. The last part of your question is how do we get a handle on the baseline energy use of CEA facilities? And I feel like that's a whole extra can of worms.
Yeah.
Um, and the first thing I'll ask you is a question in return.
Oh,
How,
thanks.
like, are we talking about how much energy CEA facilities use on an annual basis?
Probably.
Yeah, that's where we should start is like define the boundary. We're talking about every year. Okay, great. Then let's also talk about how are we measuring this information? Where does the data come from?
Mm.
So are we talking about modeled data? Are we talking about self-reported data? Like, are we talking about sensor measured data where like a piece of hardware is measuring system level usage? Or are we talking about something like utility reported data where the utility is telling me at the meter level how much I'm using and maybe at like an interval of 15 minutes or something? So
Right. Exactly.
that,
Those
that's where I wanted
questions
to start.
exactly.
And so which one do you like best, I guess, as a person in the industry working with all that type of data, I'm sure at different times in your career?
Well, first off, I hate modeling data. Right now anyway, because we don't have data to validate the results. And maybe some folks do. Like the person I interviewed last week, or for the last episode, Jeff Kelly, he's developed a pretty robust energy model for the cannabis industry. But what about lettuce and strawberries and tomatoes? And, he's just indoor. Like, he's like, oh my God, like, don't ask me about greenhouse, right? There's too many variables there. And so it's like, okay, maybe we can figure it out for one crop in one type of facility, but it's almost like an infinite number of variations, right? And variables that we need to model. And basically what I have seen personally in the published manuscripts that are modeling energy use and that have created so much fear around CEA in the public's mind and maybe even the investor's mind is based off of the worst assumptions I've ever heard. It's like one study out of Boulder, sorry, Colorado State, they published a study and made the assumption that an indoor farm ventilates at 60 air changes per hour, like a greenhouse. Wrong. Evan Mills, basing it off of like these old school decoupled systems from like 2008 in, the Emerald Triangle of California. Nobody is doing that anymore unless you are like black market type of grower. And so I don't feel like a lot of the modelers are asking the right questions, getting the information that they need from growers, doing the surveys that you and I have been, involved in various projects to really understand what systems and how they're being operated in these CEA facilities. So I don't trust any energy modeling data. Honestly, I think just to talk about measured data, thank you for breaking those three options down. I mean, ideally, we would have sub-metered energy use data, right? For every component. That would be a dream. But we don't even have that for like the regular building sector, right? Let alone CEA. But I guess we like to restrict CEA way more than we like to restrict, an office building. So they're probably going to be the first guinea pig anyway. I'm happy with utility data. Just it's regularly metered, right? I have to believe it has to be fairly accurate, right? At least accurate amongst the portfolio that utility has, right? And so, if we can just get energy bill data, I would be happy with that.
Yeah. So I
Thank you for turning the question on me.
yeah, I wanted to find out because like I have a whole party platter of things to talk about. Hopefully sharing some data that's helpful, that's not just I'll just caveat at the very top here and say, like, this is a fun research question I've been exploring since I started my industry journey, and I continue to dive deeper with every project. But as of June 2025, I've not yet seen a statistically significant database of CEA facility energy information that's been shared publicly. And to get an industry average, we have to get enough facilities of the same type to get sufficient averages across building types and to be able to compare them. So we just don't have enough publicly available data describing a lot of greenhouses and indoor farms across a range of climate zones. So that's my caveat for all of the stuff I'm about to say. This is not something you can go and apply to every greenhouse or indoor farm. This is, like I think I've heard you say before, when you've seen one greenhouse, you've seen one greenhouse. Like,
Yeah.
they are all extraordinarily different. And if we make a box and whisker plot of things in this industry, it's usually very big. It's not very concentrated in small buckets. So I would love to say the engineering answer first of it depends, but I'm going to give some data first. So electricity. In an ongoing study of California greenhouses and indoor farms funded by Southern California Electric, Pacific Gas and Electric, and San Diego Gas and Electric, ERI has explored energy usage of a greenhouse growing orchids, which is around 65,500 square feet, a greenhouse growing cannabis and some cucumbers and tomatoes, but mostly cannabis, which is around 4.8 million square feet, huge greenhouse, and one indoor farm growing cannabis around 23,000 square feet. So we had two cannabis in this mix and one orchids. And so we're able to compare across some crops and some different facility types. And two of the greenhouses are in different climate zones in California. And each facility has a very different electric energy use intensity. The greenhouse growing orchids used around 575,000 kilowatt hours a year, which worked out to around 9 kilowatt hours per square foot, whereas the greenhouse growing cannabis used around 12 million kilowatt hours per year, but had an electric EUI of 2.5 kilowatt hours per square foot. So what systems do they use? How are they using those systems? That's obviously influencing how much electricity they're using, the crop types they're growing. The indoor farm used around 4 million kilowatt hours per year for an electric EUI of 161 kilowatt hours per square foot. So let's compare 9, 3, and 161. Like the indoor farms are obviously doing something different than the greenhouses. That's the biggest takeaway I'd say for everyone in the electricity side of things. Electricity is used predominantly by the indoor farms. Greenhouses are using other things. They're using generally more fossil fuels. So let's talk about the natural gas side of things, which people I feel like don't talk about as much, but I've been working on it more recently because fossil fuels are used a lot, like I mentioned, by the greenhouse facilities because they need to get to a target set point temperature year round and at night. And for crops that want warm, root zones, you're going to need to heat. So even in California. So we're doing a study and in the same territory for Southern California Gas, San Diego Gas and Electric, and Pacific Gas and Electric, and we completed one back in 2023. So in 2023, we gathered data for 95 greenhouses and broke them down into a few categories. And what we found is that crop types seem to matter more than facility location because in the same climate zone, you're going to have, again, we don't know how big every single greenhouse is, but we can see that they use drastically different amounts of natural gas in the same climate zone. Maybe that has to do with their size, their crop, but it doesn't seem to do inherently with their climate zone. We found that floriculture greenhouses used an average of around 74,000 therms per year. Natural gas is measured in therms sometimes, but has other units. And then the vegetable greenhouses used an average of 390,000 therms per year. So that's a big range, looking at all these different annual bills. So we found the average was around 155,000 therms per year, but I can't really tell you the therms per square foot because I don't know the square footage of all those 95. More on that later, though.
Okay.
So what do we really learn without telling you what systems they use? Crop type probably matters. Location maybe matters. But indoor farms and greenhouses inherently use energy differently. But I think we all kind of knew that. But the data is important to have to really be able to say, well, how differently? Order of magnitude differently.
Right, right. And I mean, how many indoor farms are using gas compared to greenhouses? Not
Yeah,
very many, probably.
not very many at all. So that's why
Right.
the gas utilities are really looking into the greenhouse opportunities. And then the electric utilities are looking into both greenhouses and indoor farms.
In your study, so we did a similar study, also funded by PG&E, et cetera, and looked at indoor and greenhouse facilities. Unfortunately, we don't have the same units. So I don't know if you have a problem, right? There's a topic right there,
There you
the
go.
metrics. But I mean, we did collect data in kilowatt hours and therms, but we converted everything to kBTUs.
Oh, yeah.
So I don't know if you have that ready, but I would be curious to know how our two studies compare. And let me just ask, when you did it on the area basis, was it facility or canopy area?
For the greenhouses, we were primarily doing the area of the house. So,
Okay.
and that's kind of typical of buildings, like commercial buildings when benchmarking
Yeah.
them. You kind of benchmark the whole building and subtract any parking lots. But um, yeah, I know canopy area is something that I've used for benchmarking in the past too, and that's another place that you can go. But again, you got to compare apples to apples. And I will say that the numbers I just quoted will be converted to kBTU
Okay.
in the final published study. But a lot of folks kind of work in kWh with their utility bill. So
Sure.
I
Sure.
just, yeah, just giving at least with a relative kind of comparison of some of those numbers. I think that if anybody's interested in the results of the electricity study, that's going to be published on the ETCC website in later in 2025. And then
Awesome.
the other one that I've talked about is already on that ETCC website. So
Okay.
yeah,
Yeah, I mean, we found that just in kBTUs per square foot and doing an EUI, right,
yeah,
was that indoor was and for cannabis specifically, indoor was almost twice, not quite, maybe 75% greater than greenhouse overall when you combine electricity and gas together. And that's across the state. We did find a big difference between greenhouses operated in Monterey County versus Sacramento County, which shouldn't, well, I don't know. Maybe it's a surprise. Monterey has a very nice climate, so they probably didn't need a lot of heating and cooling. I think they were more reliant on supplemental lighting, as, what they needed energy for, especially on those foggy mornings. Where in Sacramento, one of the greenhouses that we looked at was air conditioned. It's
Yeah.
like my biggest pet peeve of a greenhouse is an air conditioning the sun, but whatever.
You bring you bring up a good point. Both of my studies were separately funded by the electric utilities and then gas
Mm,
utilities. So
that's
both of my
interesting.
data sets were not combined for these studies because they were not funded by,
Yeah,
for example, a utility that only cares about both gas and electric. There are some in California that do both, but in the CalNext program, it's all electric. And then in the statewide gas emerging technologies program, it's all gas. So like all research, who funds
fascinating.
it? Who funds it?
Yeah.
That's what directs
What they
your
care about. Yep.
what they care
Yep. They
about.
put their blinders on to everything else. Well, thank you for sharing that data. I'm really excited for your report to come out and to have more facilities to add to the very small sample size
Mhm.
that is, like you said, publicly available. And eventually we'll get to, I don't know, 30 per facility type, plus 30 per crop type, plus 30 per whatever.
Yeah.
We
I
know
think that
all
there's
those facilities exist, by the way. There is no lack of facilities to be able to collect this data, right? To collect a representative sample.
it just takes time. We've been working at Cornell University's Greenhouse Lighting and Systems Engineering Consortium on a benchmarking project with NSAVE for
Mm.
several years now. And of course,
Jeez.
it started during the pandemic, but we've finally gotten to 45 greenhouses in the state of New York.
That's
So
awesome.
that's a great thing to celebrate, and we hope to share some data with that soon. And so these buckets of data will start to emerge, but having a national data set is going to be challenging, and hopefully it'll improve over time. But I just wanted to mention some of the when we're talking about what's the average for energy usage. I think that what year do you think that that'll be had? Is it 5 years off that we might understand what the average greenhouse or indoor farm uses for these fuels? Or are we just going to continue to say, well, it depends, and it depends on all of these variables?
I mean, it depends for sure. I would like to think it's 5 years, but already when we published our survey, it was 3 years ago. So by the time you publish yours, that's 5 years, and that's still a pretty small sample size. And I think one of the biggest challenges, right, is people's willingness to share that data. I feel like maybe those barriers are coming down a little bit. And what I have found really interesting is that cannabis growers have been way more open and transparent than lettuce farmers. It's kind of interesting how cannabis farmers came out of the closet and out of their garages and basements and, hiding from the feds. And now they're like, no, like, here, please help us and help legitimize this industry. Which I wish that vertical farms and non-cannabis producers would apply that same spirit to transparency and sharing, because it's only going to help the industry as a whole. But hopefully, kind of like we were talking at the beginning of, your answer to, why energy is important in CEA or why it's a hot topic, is that hopefully growers realize that they can save money, optimize the performance of their facilities if they do pay attention more to energy and reach out to folks like you and us to help them manage their energy better. So I don't know. It depends. I'm gonna have the engineer's response, but it's probably like 10 years, honestly.
Yeah, I think that transparency is maybe not the goal for right now. Just having people
Yeah,
actually measure it themselves and even keep it to themselves, fine. But like
sure.
work with teams to make it better. And I have had some success stories with folks, doing some actual energy efficiency projects to benchmark and improve energy consumption. It's just kind of not as big of a priority as some of the other projects that might be going on right now. So I think that benchmarking, while important, probably not going to be something that people prioritize in the next 3 years, perhaps.
Right. I want to ask you this question. Why do we care about energy efficiency? You kind of made a comment at the beginning about, the strain on the grid and trying to reduce energy use and just making sure that, all the customers within a certain utilities territory, right, can serve the needs of their customers. But I was just wondering, would you mind going down a rabbit hole with me for a second just to talk about the value of efficiency?
Yeah. I think that, like I mentioned at the beginning, because energy costs always go up, what I mean by that is that the utility rates always change every 3 or so years, usually. Sometimes, if you're lucky, maybe every 10 or more years, but in general, they get changed every few years and the rates go up. And so you're paying the same, maybe even if you use the same amount of energy, you're going to pay more for that same amount of energy just because the rates changed.
Hmm.
So the opportunity for energy efficiency is resiliency in the face of that escalation cost. So
Okay.
you can leave every system the same, and you can also just practice energy conservation, which is something that I haven't mentioned yet today, which is something that I think is an equitable activity that doesn't require as much capital. So I think that the opportunity may not have as many, rebate eligibilities, like you may not get a rebate for changing your set point, but that will in fact reduce energy usage if you just kind of take a look at how it affects the crops and realize, okay, well, now this piece of equipment's running less often. Okay, that was a good, efficient strategy to do. But overall, why does it matter? Because running a business costs money, and energy will always be one of those baseline costs, whether you have a really amazing, innovative staffing strategy, or you've come up with this ridiculously fantastic production line that is just like slashed all of the other costs that affect your profit margin. Like energy is just still going to be there. And a lot of folks just pay the bill every month. And usually it's the person paying the bill who's not in charge of other choices like capital investment in better equipment or standard operating procedures that the growers follow. So one hand shakes over here and pays the utility, and then the efficiency activities are happening
Mm.
in a different vertical of the business. So the reason it matters is because like organizational design and strategic energy management requires a connected operation that actually cares about reducing that cost. And some folks don't have to. Maybe they've got some mothership like a global company and just paying that energy bill and it don't matter, right? But like a
Right.
lot of the folks we work with are family businesses or they're trying to expand to the next spot. So they've got to optimize costs at the first one if they're going to afford to build the second one.
Thank you for making a business case for energy efficiency or energy conservation and describing the difference between those two. That energy efficiency is, yeah, you're doing that to reduce your energy use, but conservation is really more a mindful reduction of how much energy you're using. I think that's a really important caveat between those two because it's energy efficiency that the utilities are valuing by giving you incentives and rebates, right? Is they're saying, okay, we want you to use less energy, and so we can't force you, like you said, to change the thermostat or maybe change some of your practices, but we can encourage you to select and install more efficient equipment with kind of the same hopeful outcome, I guess. But it's really up to the grower to decide to use less energy, right? And because I guess one of my biggest complaints is the use of switching from high pressure sodium to LED lights or just a more efficient LED light is that, what I see happen a lot is that growers say, "Oh, now I have all this extra power I'm not using." And so it's just like, well, what did we just incentivize? We just incentivized you to use the same amount of energy, not reduce your energy, not reduce your strain on the grid, not reduce your carbon footprint, right? We just encourage you to actually install more and grow more, which is not necessarily a bad thing. Obviously, we're in the business of production agriculture, but it feels inauthentic.
You've touched on a key conundrum of energy efficiency. It's like actually something that kind of I'm glad I didn't learn about when I started my career because it would have made me more jaded. But like essentially research has shown that energy efficiency as an industry just results in inadvertently increased energy consumption because as we find ways to make the existing processes more efficient, we find new ways to use that energy. So what's the great example that we can think of today in the past 10 years? Data centers and AI.
Yeah.
So we wouldn't be building data centers all over the freaking world if we hadn't
Mm.
done energy efficiency for the past 20 years because we would have had to build so many more power plants for those data centers. But we didn't have to because folks like me have been working for the past, parts of our careers trying to get folks to change out equipment so that, Meta can build a data center in 2025. So it does kind of hurt my heart that ultimately efficiency isn't a silver bullet to reducing energy use. It's actually what you've touched on, which is the operator's choices. How are you choosing to control the equipment that we've installed and maybe given you a rebate for? Is it like dimming the lights? Is it scheduling the lights? Is it doing daily light integral controls for the lights? Definitely something that I'm looking into a lot with greenhouses because that's potentially a way that you can have folks not maybe have to change out a ton of expensive equipment and just start to be smarter about the way they're operating things. Other things include like we touched on set point optimization, like see how set points affect the way heating and cooling systems and ventilation are used. And then overall, it's just like actual behavioral practices. Like, are we doing things like leaving things on? Are we turning things off because we know it's not going to impact the product? Like, if you're just having a mindset, like we talked about, a kind of philosophy of energy conservation, then energy efficiency and rebates and all of that stuff, that's a nice cherry on top, but ultimately you're actually reducing energy use at the building. And that's
Yeah.
really all that matters when you're trying to have a business survive.
Yeah, I mean, I think, yeah, user use is underrated, and we kind of all live under the human condition of more is better, right? And so it's like, oh, more photons, right? More photosynthesis, more yield. Well, okay, yeah, more photons, but then you have to increase CO2 and you have to change your temperature and VPD settings. And now all of a sudden you're chasing energy, right, to get how much output, right? And I think, amongst this conversation, if we're thinking about, plants converting light energy into photosynthetic, outputs, how many people are doing the research, whether it's in their facility or in an academic institution, to figure out, well, what is the balance between all of these inputs to achieve, right, the end goal? Is the end goal always more? Is it better quality? Is it just, a more consistent product? Right? Like there's so many variables that we have the opportunity in CEA to manage. It doesn't always have to be more, 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 more. And in fact, what we have seen is when, for if we design a perfect HVAC system for a facility, they're like, oh, it worked so great. So we threw in another row of plants and it went to shit. And so then we ripped it out. And it's like, yeah, more wasn't better in that case, right? Like we optimized the system specifically for the original design criteria, the original condition, but now you thought you could get more out of it and you couldn't. And so I just feel like finding those optimized points, and I think set points is a great example of that. We know with lettuce and tomatoes and a lot of our traditional horticultural crops that it's average daily temperature that matters. It's not necessarily holding, right, that VPD consistently during the photo period and then changing it during the dark period and meeting that every single time, those targets every single time. It's as long as you hit an average daytime temperature of 22 to 24 degrees Celsius for tomatoes, you can hit. I'm going to totally change units on you. You can totally let the greenhouse ride to 90 degrees as long as you can bring the greenhouse down to say 50 or 55 degrees so that you get an average daytime temperature of 72. There you go. I'm just playing with units now. Right? Like that's awesome. What a great energy conservation technique. That means we don't need to, hit the accelerator every time on cooling to bring it down to 80 degrees or on heating to bring it up to 60 degrees. We can let it
It,
ride, right? Like we
it,
can,
it brings me back to my upbringing in, buildings with humans. It's
yeah,
increasing the dead band. Let let hysteresis happen. Like the tomatoes outside experience some fluctuations
right?
day and the night. Let's like that we know inherently that we don't need to play like an OCD god where we're like constantly keeping the targets at every single moment. Because energy efficiency in commercial buildings is also had by just being a little bit lax, maybe not lax, but I mean, a little bit more relaxed with the
Right.
deadband, saying, hey, we don't need to have the equipment turn on when the temperatures and the humidities are in this band. And when it does, turn it on, keep it out of there. And then same thing when it's down here, when it's heating, got to keep it back in the dead band. So, but that sort of stuff is like, it's bleeding from the commercial buildings industry into CEA, but CEA facilities are mission critical food production or other types of product
Mm,
manufacturing facilities. It's different than an office building. We can't just say, hey, deal with it, office workers. It's like, no, this is a product we've got to sell for a certain amount. So to your point about quality, I would love for us to have more research on some of the stuff like how much yield are we getting out of these facilities for the energy we've put in. I see mostly that coming from the academic community. They're the only ones really funded to do the yield values. The utilities don't care as much about that, so they generally just fund the electricity tracking and the natural gas tracking. But the other sorts of qualities like taste, scent, just things in floriculture that I'm not even familiar with, like those are things that
right.
we like don't benchmark them next to energy. And so I think that's up to each business to decide how. I've asked businesses from the restaurant industry similarly, how much do you want
Mm.
to pay every month? How much are you cool with paying on your utility bill every month? At what point will it be too much? And like
Those are great questions.
if you haven't thought about that, maybe don't start running the restaurant yet. Like because otherwise you're just going to be running the restaurant and you're going to be pedal to the metal. And anytime you see more, you'll say, oh yeah, more. Let's get another ice machine. Let's get another heat pump. And ultimately we'll start to have so much stuff using energy that we don't know how to make it up for with increased yields or profits. So
Yeah. Yeah. What
basics.
is your budget, right? Like, what is your what I mean, I feel like there's so much focus on revenue, right? There's so much focus on production, and there's just not a lot of focus on the other side of the profitability curve, right? Which is the inputs, the costs, the expenses, right? But profitability is a two-sided equation, right? It's what comes in and it's what goes out. Everyone is like, oh, prices are going down, right? For cannabis, prices are going down. We got to produce more to make up for it. Well, wait a second.
Yep.
We are already oversupplied in a lot of mature markets. We don't need more. We need you to use less to produce the same amount.
Yep. Yeah, I think that it's also sexier to talk about producing more. It's sustainability was maybe cool for a bit, but I recently said to someone that like sustainability was cool until it started to include accountability. And
Ooh.
so we aren't talking about it as much because it would require talking about those expenses. It would require being transparent about the maybe the not as sexy side of the coin. Let's just keep talking about how many racks we've installed. Let's keep talking about how much we're producing with less water, maybe, but mostly just talk about how much we're producing. But the measuring of the energy, that's not as cool and not everybody's doing it. So being the first person with your foot out there, nobody wants to get kicked in the shin. So they're all sort of waiting to see. And I get it. Why would you? No one's, I've said also on other podcasts, pay people money to share this information if you want it so bad.
Yeah. I mean, that's a
Business,
good point.
like,
Is like if you're the first one to put yourself out there and, it's a million kilowatt hours per year, honestly, you have no idea if that's a good number, a bad number, an average number, right? And it's not until more people come forward and say, I use 900,000 kilowatt hours per year. I use
yes,
2 million kilowatt hours per year. Now all of a sudden the person who was out there first is like, "Oh, I'm not doing
I'm
so
not so
bad," right?
bad.
Yeah.
Yeah.
But then the 2 million kilowatt hour person person is like, I don't want to put that out there because I used twice what the last person said. So it is totally a conundrum. Yeah.
Yeah, that's why I brought up those numbers in the beginning of this answer because I was like, it's like a Jackson Pollock painting. There's dots all over the board. We don't know yet if there's a trend line. We don't know how to maybe categorize them all yet and put them in the right buckets. So yeah, 1 million kilowatt hours is a number I've seen for a CEA facility. I've also seen 500,000. I've also seen 60,000. It depends on the size. It depends on the crop. It's like, that's why no one wants to talk to engineers because we just keep saying it depends.
We're good at that. So, you know, on this note, you've brought up a few times like, your past and you studied energy engineering. How did you, by the way, get into CEA? Like what, I don't know, sparked your interest?
Well, I live in Vermont and I had been working for the local energy efficiency utility here in my region, which is the Burlington Electric Department. And I'd been working with big commercial accounts like the University of Vermont and the like 90 some buildings they've got on their campus. And I was working with the city of Burlington and benchmarking fire stations and city hall. And like I mentioned, I was working with restaurants and chocolatiers and all these sorts of folks using energy and trying to help them get rebates, of course, but also just like educate on energy. And so I was doing some research as the state legislature legalized the home growing of cannabis. And I brought it up to my boss. I was like, do you think we should like do anything to help if people start growing cannabis? Like, should we do like an educational page on the website? And that's sort of where it started going. I started researching about energy use in cannabis, and that's where I found out about RII and started to understand that we did have, I did, of course, see some sensational stuff from, the early days of cannabis energy reporting. And so I was like, oh, we should make a rebate program for grow lights in the state. And so I actually collaborated with Efficiency Vermont and we launched a grow light rebate program in 2018, which was fairly early on, and we offered it to
Yeah.
home growers and commercial growers alike. And that's really where my career pivoted, and I saw it as an opportunity to take what I've learned in commercial buildings, like all those different types of buildings I just mentioned, and translate it for the CEA industry. And at the same time, learn a ton about an industry that I didn't know anything about these buildings. Like you have a background in agricultural engineering. I learned about buildings with completely different types of thermal envelopes, completely different types of HVAC
Mhm.
systems. The lights turn off when people go home, like all this sort of
The
stuff.
HVAC system turns down, right?
Yeah.
Like it has a
Yeah.
chance to rest for 12 hours.
I had a lot to learn. So I just was passionate about it because of that, what I felt like was going to be a potential impact to energy equity in the state of Vermont, but also just like because the federal government won't research cannabis, I was driven to help the energy efficiency of the industry through that work that I did with RII. And then since then have been able to do more work in the non-cannabis side of things through the utility funded research that expands it to floriculture and food. And so that's where the work keeps going. But I still work in buildings with people too, because I think that we still have a huge energy challenge with those buildings too.
Yeah. Not a lot of people can talk at this level, so I'm actually curious to get your thoughts on this. So, energy standards, codes and standards started at least in California in the 70s. I imagine ASHRAE and other states probably followed suit very quickly soon thereafter. And, we've had what, 40 or 50 years of moving the goalpost, right? But always focusing on energy use and efficiency and conservation in the built environment, whether it's residential or commercial, industrial. Agriculture is a very new kid on the block. And when you look at sort of the evolution of energy codes and standards and incentives, and even LEED, the U.S. Green Building Council, there's been time to for the industry to evolve and change and, and to implement, I guess I would say, sort of incremental energy efficiency measures. We didn't go in a 4-year period from, you know, metal halide lamps in a studio to LEDs, right? Like there were like five, we went to fluorescence and then we went to better fluorescence and then we went to LEDs and who knows what's next. Now there's natural light, daylighting, right? That people are advocating for even in hospitals. Where before it was like close everything up. Oh yeah, maybe fresh air is good and fresh sunlight is good, right? Like the built environment non-CEA has had this time to make incremental adjustments. But when it comes to CEA, sometimes I feel like it's gone from like 0 to 100 without necessarily having all the research and experience that was behind, right, commercial and residential buildings to demonstrate that, oh, having, this R value is better than having that R value. And we have all this data now to prove it, right? Or, this HVAC equipment versus that one, or this lighting versus that one. Like for us, it just feels like you're going to use LED lighting. Like don't just skip fluorescence. Just skip everything that's in between and this is what you're going to use. So, I guess I'm just kind of curious your thoughts on that.
So I thought of a lot of things while you were talking, and one of them is like that the CEA industry being the new kid on the block is sort of like how in the global landscape for energy, uh, nations that have not had time to develop renewable energy are being told to adopt it right now.
Yep, yep.
Whereas nations that have had money and time to develop renewable energy got the time to do it and got to use coal for a while and got to use natural gas for a while.
Good
So I,
point. Yeah.
I see it really similarly. And I do see, especially in our fair state of California's energy code, of which I'm very, proud of all of the teams who work on the energy code in California and all of the ASHRAE teams who work on standards like this. None of this is to say anything against codes and standards. But I do feel like the way codes and standard development for CEA has happened has been in tandem with the energy research instead of being after the energy research. And
Yeah.
so we're having literal teams. I talked last week with the case team for the California Energy Code version 2028, and have been learning what they're developing for daily light integral controls for the version of the code that'll go into effect January 1st, 2029. Meanwhile, I'm still doing research funded by the California utilities to investigate the energy savings of DLI controls, and they don't even have the report yet. So I'm talking
Yeah.
to the case team, and they're like, "Oh, well, they'll have 3 years." And I'm like, 3 years to launch a rebate program and get all of the growers to adopt DLI controls? That's not the amount of time commercial buildings got to adopt fluorescence and LEDs and lighting controls like daylighting and dimming and all that. It's just not fair. So I'll just say that there's not much we can do about it, but it is definitely different. And like we are just seeing, I think, the sort of attention that we talked about earlier because of the media and other sources talking about energy intensity from these facilities in a sensational way. We kind of have had the stick of codes hitting us a little faster and harder than we might have had if folks weren't talking about, the grid and being in danger because of indoor farming.
Right. Thank you. I always feel like the elephant in the room is our data centers and, Chat GPT, right? It's like, who cares?
Yeah, why are you hitting the growers, the folks who are feeding the country, providing us with beauty through floriculture, medicating the country with cannabis? Like, why are you hitting these folks? It's sort of similar to like the sort of attention that casinos have gotten, where like they're vilified for existing. And it's like, don't knock a function of society, whether it's entertainment or something else, like please treat it just as they should be standards. Codes should be the minimum bar of performance. That's something I also didn't mention. It's just like codes are not supposed to be the energy efficiency program. They are supposed to function as the bar at the bottom that everyone should be able to get over. And that's the energy savings the codes can claim. then the savings, the energy efficiency folks can claim is the difference between the code baseline and whatever they're offering. And so when the code baseline is like here, there can't be a rebate program. So I really wish codes would just continue to just be codes and stop trying to be efficiency programs at the same time.
Wow, that's K profundo. Nobody has ever explained it that way. Thank you.
I have a little bit of a bone to pick, but I mean, I function in it all. Thank you.
I knew you'd be fun to talk to, like mines. Okay, so where do you see energy being wasted the most in CEA?
Well, I think I'll start with an answer that's applicable to all buildings, which is just turn it off. Like, like in your house, right? You're leaving the lights on in rooms that aren't being used. You've got equipment that's just running all the time. Those base load pieces of equipment, why are they on all the time? Do they have to be on all the time? Do they have to be on all the time at that highest max power? Can they be modulated? Can they be dimmed? So the turn it off mentality, the tweak and peak mentality is where I see waste. It's just if you're not employing that question, that curiosity of like, why is it on? Why is it on all the time this way? Then I think that's where I feel an opportunity is. And waste is all relative, right? We got back to the production side of things. So folks might not see any energy usage as waste if it results in
Mm.
the sorts of results that they want with their product. So we've talked with growers where they're like, we've got a mothership, they pay the energy bills, and all they care about is the quality of the product. And so for us, the interest we have in energy monitoring is mostly to see, like, is it worth replacing some systems that are using more energy than we expected? But we're not maybe going to change our practices, right? So that was an interesting insight. Having the business case for a capital project is kind of like where they saw it. But waste, I feel like is where we talked about before. It's like how you use it. Is it controlled well? Is it controlled by hand?
Yeah.
Is it controlled by a switch that someone's touching? And that's probably not the most efficient thing. Is it controlled instead by a timer? That's better. But is it controlled maybe instead by a sensor? That's even better. So
Hmm.
I feel like I like to think of it as a stepping stones to being energy efficient. And everyone has a relative definition of how energy efficient is worth it for me. And so not everyone's going to get to a net zero energy greenhouse. I have not heard of one. I've heard some folks touting that they're working towards these sorts of really aggressive and very commendable energy goals. But like, how efficient is it worth it to be? And then find the strategies that will trim off the waste to get you to that. Because some folks maybe have a ton of waste because they're not taking a look at stuff. But maybe a lot of folks are looking at stuff actively and there's really not a lot of waste to take away because they've got their SOPs and they've got to follow them that way. So,
Right.
yeah.
Yeah, I mean, I think that's really a good point about turning things off or understanding why you have everything on all the time. I made the mistake a few years ago. A greenhouse operator came to us and they were like, we're struggling, with managing our climate in the greenhouse. And so they're explaining to us like what systems they have. And so they have a wet wall. They have, it's positively pressurized, but they also have air conditioners and dehumidifiers and horizontal airflow fans and vertical airflow fans. And I don't know, just like every type of system that you could possibly think of. And the mistake I made is I said, well, we could help you save energy by telling you how to operate these equipment, in sequence with each other or when you need them. And they just right away were like, we don't care about energy. We just want to grow a better plant. And I was like, oh, like I should have known better but all I saw was, oh my God, like your greenhouse is just gobbling up energy by running all these things all the time. Like that was my first gut instinct. But those equipment are also all competing against each other, right?
Yeah.
And so like you have just the fans alone, some blowing horizontally and some blowing vertically. How is either of them supposed to do their job? Now they're just blowing at random angles, right? That you could never even model if you tried to in a simulation. And having air conditioners and a wet wall on, and they're like, like we can't manage the humidity. Well, no shit. Like turn something off. Like which one do you want?
Yeah, and you're touching on something I was going to mention, which is again a commercial buildings industry term that should be used more often in CEA, which is staging of equipment and the sequence of operations of that equipment. What are the dead bands? How does the fan turn on? Does it turn on because of a set point, and which set points? And are there high limits? Are there low limits? I really feel like, in commercial buildings, the controls contractors give these big, you know, sometimes they're boilerplate, but there's still these big documents that explain how the equipment's supposed to operate so that when a commissioning agent comes by, they can run the sequences and find out, hey, did the system turn on when I told them that the outside air temperature was this cold? Did this other system turn on when I said that it was this humid inside the greenhouse? Did I simulate that environment and actually observe it turn on? Like there's testing that I would like to see happen more often because we don't really have the controls staging sequences written out often, or I'm not seeing them often. So
Yeah, or it's completely black box. I mean,
yeah,
a lot of times when we're helping existing growers just improve what they have with what they have. We're looking at trend data, we're looking at the controls programming, and I mean, it's so complicated, and a lot of times like if a grower wants to make a change, like just yesterday, I was like, can this system control to dew point temperature? Like you have all these other variables. I mean, it can calculate dew point, but I don't know if it can manage to dew point. And they're like, "Oh, I don't know. Like we're gonna have to ask, right?" Like that's not that big of a deal, but it's just like a lot of times growers have to go to that controls manufacturer to make a programmatic change. And if that's going to be the case, then, a lot of these controls companies, unfortunately, are not in the same time zone. We'll just put it simply that way, right? As the growers. And so, like, if you want to make a change now, it might take 2 days to communicate that to somebody in another time zone or country. And then by the time it happens, it's a week later and it's no longer spring, like it's.
yeah, I think you're hitting on a great touching point too, which is black box controls have been vilified for years in the commercial buildings industry, and we
Mhm.
don't really treat them like that here in CEA. We sort of accept it. We're like, yeah, factory controls. And I do understand the importance of having the manufacturer have some level of involvement in how the sequence is executed, but give the growers more information, like you said, on their graphic interface, allow them to make logic changes more easily and faster, because when folks are locked in, it's just not really like a good business practice. I think that folks can make their choice to work with, the sorts of systems that are going to require them to continue to subscribe and continue to invest in that same system. But growers should have the freedom to use multiple systems and have them all on one screen. But,
Yes.
we are not in that day and age yet. Even the most sophisticated growers still have to have these multiple monitors and compare and contrast and make their own spreadsheets to bring everything together. So
That's true.
waste,
That's true.
waste isn't always easy for them to find when everything is on different platforms and they can't change a logic sequence quickly.
Yep. So, what do you see as some of the biggest barriers to reducing energy use in CEA? I think we've touched on several of them. So, maybe summarize what we've already talked about, and if there's anything else that comes to mind that you think is a barrier to achieving energy efficiency or conserving energy.
Sure. So I've been doing research like you have in this space for a while and have been asking this question a lot. And so I have a short list, and then I have this like longer list that has to do with participating in rebate programs. So
Mm,
the short list is, I don't want to do an energy efficiency project because it's going to disrupt my operations and that's not worth the effort.
okay.
Easy peasy, right? Like you and I have done plenty of that when we're looking at a house project, right?
Yeah.
So
Yeah.
the disruption to operations is not worth it. Uh, Same thing with first cost, right? First cost of
Yeah.
materials or the labor, like it costs too much. They might not trust the system's performance. Like when LED horticultural lighting came along, a lot of folks
Oh,
were like,
yeah.
I don't think that's going to perform the way I have enjoyed with my current system." And then training. training people on new systems may be required, and that could be a barrier. It's usually not the biggest barrier, but it is one. And then availability of labor resources to complete the project. Maybe you don't have labor on hand internally that can do it, so you need to hire out, and maybe that's going to be a certain amount of time. Like in Vermont, we don't have enough contractors to complete work, so it takes time to get projects done.
Interesting.
In rural areas, that can be the case. So my second part of the answer is, why haven't people participated in a rebate program, which can often be the reason why they haven't done an energy efficiency project. So they might not have gotten rebates before because they're not aware of programs. So if a program's not creating enough awareness, a grower might not even know that there's an energy efficiency rebate, and so they might not think about energy efficiency or do energy efficiency projects because they've got other projects that are more important, like a new production system or a new, IT investment. Like there's all these other things they could be doing, like for HR or for other operations.
Yeah.
Folks might not know where to find out about programs. There's language barriers, and folks don't have the ability to navigate language barriers to get a project done, to get rebates. They don't have time or staff resources to participate in rebate programs. And so just like not completing the project due to time or staff, they're not going to go after a rebate because they don't have time or staff. Programs aren't offering enough money, so maybe the rebates aren't big enough, and so it's not tipping the scale to make the grower do the project. And then getting rebates takes too long. So you and I
That's a good
know,
one.
and growers listening know, like if the rebates take too long and the efficiency project takes a long time, let's just not even talk about it. Let's just do something else. Let's just deal with this current system we have and replace it when it fails.
What's a long time?
Sometimes growers are ready to do a project after they've gotten a quote from a distributor, and they're like, let's go. But let's go and apply to the rebate program first. Maybe they didn't think to apply to it until just then. And so if they apply right then, they usually have to deal with a few weeks of pre-approval. Then they have to install the project, and then they have to deal with the final approval. And those two approval time periods can vary widely, especially if it's a custom project. And so if it's a sort of easy peasy, standard lighting project that maybe it's like $1 per fixture rebate, that might only take a few months. But if you're dealing with a program that's maybe more custom, or maybe they don't understand your operation very well, sometimes they want to do an inspection. It can,
Really?
yeah, it can end up, if it's a custom project, like I've been doing some DLI controls projects, the utilities want to verify the data. They want to see how it's working. And so the rebate can sometimes take a whole year. And so if
Oh,
you would,
wow.
yeah, if you would, and in California, some of the natural gas rebates, they're pretty much like many of them are custom. And so like if you're not doing a greenhouse curtain, or if you're trying to replace a boiler, it can be a bit more complicated. And so those large capital investments, which you're going to be spending, maybe 50 or hundreds of thousands of dollars on, you don't want to wait a year to get that money back. So you might as well just table it for the capital plan for next year and hope that the rebates get faster, or maybe hope that there's more money from some other source. So those
Interesting.
are some reasons why folks don't do efficiency projects. There's lots of other priorities, right?
Right, right. You made me think of a question that we've been pondering over the last year or so as some of our clients have asked us to help do some studies on decarbonization of their existing facilities. I'm kind of curious your thoughts on the electrification of CEA. I think indoor farms, maybe that's a no-brainer, but with greenhouses, what do you think it would take to electrify a greenhouse?
It's very interesting you ask, because I'm going to be giving a class on indoor ag resiliency for PG&E this week, and it addresses both indoor and greenhouse, and it tackles energy efficiency, electrification, and on-site energy generation. And electrification is one that is really tough for me to recommend to greenhouses because of what is called the spark gap. And if you haven't heard that term
I
before,
have not.
it's a fun term, right? It's kind of cute. The spark gap is the difference in cost between natural gas and electricity. So if natural gas is cheap and electricity is expensive, the spark gap is very big. And so electrification doesn't actually save you money. It actually costs you more money.
Mm-hmm. Mm-hmm.
So electrification of greenhouses, I've gone to some greenhouses. Have you seen the size of those boilers?
Yeah, they're
Like,
giant.
so do tell how many heat pumps we need to satisfy that, and what size electrical service would they need to install all those heat pumps? Because that's for me, I'm not a design engineer, and I appreciate those of you who are. I just think that that's a conundrum that the utilities aren't solving for the growers. And so the growers have every reason to continue to use fossil fuel, and especially if natural gas is affordable. And they've recently upgraded their systems to perhaps like have good condensing boilers, and they use root zone heating, and they maybe aren't using all those systems, like you mentioned, competing all the time. Like maybe let them continue to use the fossil fuel. And I wanted to mention that like decarbonization doesn't only mean electrification. And I think that the electric utilities have
Mm.
really like focused on us thinking that, because the natural gas utilities would like to remind us all that decarbonization can mean reducing the amount of natural gas you use, which can still mean using natural gas, just reducing the use that you have, like energy conservation. And it can also mean reducing the carbon content of the natural gas you use. So that's why the natural gas folks are pushing renewable natural gas on all of us, right? So if you've heard of renewable natural gas, it's like, oh, we're going to push, cow poop fumes through the pipeline along with your natural gas, right? And so
Right.
it's technically decarbonizing, right? We're reducing the carbon content of the fuel. So I think that if folks are in a rural area with limited electrical service, if the electric utility is going to make them pay for the electric upgrade, which is often the case if you request a service upgrade, you're not just getting it for free. It's you got to pay for the upgrades to the line.
Yeah,
So why would you do that when you've got a perfectly good giant boiler?
exactly. That might not even
Yeah,
be that old, right? It could be 5 or 10 years old. I mean, okay,
yes.
maybe there's some greenhouses out there where it's 40 years old, but boilers are simple pieces of equipment. I mean, they're not a lot of moving parts, right? There's a flame and like some valves for gas and air.
Yeah.
Yeah, yeah, exactly. And one of the things in talking to some folks at PG&E is that they also recognize that a lot of greenhouse growers aren't on regulated energy, right? And so, like, if the incentive is about reducing your regulated energy use, regulated meaning it's coming from a utility, is that if you're using propane, right, or if you're using diesel fuel or something else because you're in a rural location, that it's hard for them to, and you might not be keeping records, which probably most growers are, but if you're not keeping records of how frequently you're replacing your propane tank and at what volume or whatever, then it's hard for them to justify, again, thinking about the grid and the utility to incentivize you switching to the power grid if you're not even relying on the gas grid. I know grid isn't quite the right term, but
Like pipeline. Yeah.
yeah, yeah.
Yeah.
Anyway, that's also a barrier. And we looked at heat pumps to replace some condensing boilers for like a 40,000 square foot greenhouse. And the amount, I mean, depending on if it was air source or water source heat pump, which by the way, water source heat pump, now we need a source of water. That's also a challenge in a lot of locations. But just air source heat pumps alone, like, okay, it's efficient, but now they have to upgrade their power, right? Their transformer, upgrade their power supply to the site. But they're also take up a lot of space. Right? Because I mean, if you think about a heat pump, I mean, it's trying to extract heat from the cold air. And this is in California. This isn't even that cold of air, right? I mean, the site they had a boiler room that was like, I don't know, like 20 by 20 or something. If they switched to air source heat pump, they would have had to like build an area that was like the size of the greenhouse. Like it was insane, and it's just
Yeah,
like,
that's why we
yeah,
see the indoor farms with their roofs completely covered in units because like that's what's required if you're going to really control the environment. And that's where I ultimately only see greenhouses able to be electric is if it's almost like an indoor farm. It's just got a really nice roof that allows as much sun in as possible. Like it's really not great to electrify buildings that are made of glass or polycarbonate because as we all hopefully know, like those insulative values are poor.
yeah.
You're just now heating and cooling the whole environment, not just the greenhouse, because like they're usually a little leaky because they're opening vents and
Right.
a little. And then when they're not, they're just radiating the heat out of them. So
Yeah. Thank you for talking about that with me. It's going to be a really big challenge. And again, I think that there's bigger fish to fry than, some greenhouses and using efficient boilers. And maybe they're even using the flue gas to dump the CO2 into the greenhouse, which talk about decarbonization. I mean, it's not the most efficient use of CO2, but it's something. The plants will appreciate it.
yeah. And that's something that they are like going back to the business practice and business case. It's like they want that for the plant production. So if you can convince them to do stuff because it's good for the plant production, great. But if you're convincing them to heat pump their entire facility, whether that's air source heat pumps, water source heat pumps, or heat pump water heaters, all of the above, like it's not going to potentially make it better for the plants. So why
Yeah.
are you doing it? It's not to say that heat pumps can't condition the environment of greenhouses and indoor farms. I just am not seeing it as the most cost effective or best for the business.
Right. Which I think is what the US Green Building Council did such a great job, right, of making the business case for energy efficiency, water efficiency, better materials that aren't off-gassing formaldehyde and, creating like good indoor air quality, not impacting the site, that they really made a business case for it. Like you're going to save money, you're going to attract better tenants, your employees are going to be more productive, blah, 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 blah. Like we need that kind of like groundswell within our industry to make that same business case for, I don't know, having a positive impact or at least a less negative impact, because it produces more, right?
Yeah, we've seen this. It's possible. The industrial buildings community has its own strategic energy management protocol. It's called ISO 5001. It's actually like 50,001. But anyway, it's a way for folks to walk the walk and get credit for being a good steward, a good industrial manufacturer. And I think we've seen this similarly a little bit with like good manufacturing practices becoming a
Mm,
thing people want to be certified for, but the energy component of it is not something that's kind of rising to the top. But I think that as certifications and credentials continue to actually emerge in this industry, maybe there will be a actual badge that people want and they will see it as a marketing value. That's what it all comes down to, right? Like the
that's true.
reason Lead succeeded is because it was kind of founded by some marketing folks. The real estate folks were like, we can get tenants to pay more money. Like that's what the
Yep.
goal was. So
And
we
you
have
get
to,
this really cool plaque on the wall. Yeah.
yeah. And we actually made the plaque cool. We haven't made something cool for the CEA industry to want yet. So I think that
Yeah,
there are
that's a good point.
folks developing
And
it.
And the other thing I think about with lead is that also was not overnight. I mean, I started when I started working as a mechanical engineer. The thing that kind of caught my attention was lead. I was like, okay, if I'm not doing agriculture and I'm not doing plants, then what's going to make me feel good about working in buildings is going to be sustainable buildings. And luckily, I worked for a company that was interested in that too. And so, that was in 2008, 2007, 2007. Oh my gosh.
Yeah.
And it was still fairly new. Like I think lead version 2 had just come out. And now we're on to like lead V5 or something. And and at that time when I was just getting into it, contractors were complaining, bitching and complaining about having to source materials locally and having to keep all these records of where they got their materials, right? And I'm doing energy modeling, right? Trying to demonstrate that we're using less energy than some baseline standard building, et cetera, et cetera. And now it's just in the lexicon. Now it's in California, some of that is codified because now that is the minimum standard. But it took 25 years
Yeah.
to get there.
Just like we talked about giving the industry time to adapt and adopt new technologies and efficiency, we sort of have to allow things like LEED, like certification systems happen after standards and codes are well defined and industry practice is well known. So you're right. Like I worked for the U.S. Green Building Council after I graduated from grad school, and I had been writing research projects about LEED when I was in undergrad, and got to kind of see how it was like rubber hitting the road, in 2013 or so, and
Hmm.
people were still bitching about it being expensive to do it, and the fact that, well, we'll just do things like LEED. We're just not going to go after the certification because it's not worth it. We'll just kind of do it like they say, but not go through the process. And so, yes, give it 25 years. Like we've been talking about LEDs for 5 years. So maybe we need 20 more years before there's going to be some cool thing for people to drive towards and badge their facilities with. It's doesn't happen overnight. I wouldn't want it to really, because then you end up having the codes being defined at the same time as the efficiency programs, at the same time as the certification program, and they'll probably all differ on what they think is the baseline.
True. True. And in the early days of Lee too, not even that early of days, but it was even hard to procure local materials, right? Or to procure furniture that wasn't off-gassing all these poisons, right? And now again, like as more people adopted lead and wanted, and bought into the business case and there are thousands of projects, not just hundreds of projects. It'd be actually interesting to know how many lead certified projects there are as a whole now. But now I don't know that it's easy, but now, at least architects and engineers have a Rolodex, probably. Yes, I use the term Rolodex.
I use it
Uh,
too. I still use that term. I think it's great. It's very visual.
it is a good word, right? Um, there's a lot of suppliers, right, for those materials, for those products that meet those minimum that are now minimum standards. Like 20 years ago, they were stretches, right? And that's what we want to start with is a stretch. And we don't want that to be like you've been saying the code, right? Like in 20 years the stretch can become the code. But right now we just need to encourage people to implement best management practices, figure out what is a best management practice. Right? I mean, who realized that off-gassing formaldehyde from your office furniture was affecting our health negatively? How much research, literally,
Yeah.
like went into figuring that out before that became a standard practice?
And all the advisory groups and stakeholder feedback and all of that stuff that takes time to get it right. So I
Yeah,
think we want to get it right. I think that you're right. We need the supply chains to be ready, and the availability of labor and all these other things that thankfully aren't the topic of this podcast. But like, but it's like the stars have to align and the businesses have to be ready to get certified. So I think that LEED is a good corollary. I think it's not necessarily the thing that the CEA industry needs, because it's not specialized to ag. It's not kind of
Mm,
it's just so different. So I think that that's why we kind of need some industry championed version to come out and be accurate because of academic input and commercial grower input and manufacturer and the professional service industry, who all kind of collaborate to make a realistic certification. It takes years. Yeah. Like LEED
it does.
V1, LEED
Yeah.
V1, like a very long time. So
Exactly, exactly. And there is a version of that seeds, CEADS, that was developed right through some stakeholder meetings, but it hasn't really gone anywhere. So,
I
um,
was going to ask you if you think like ESG reporting is something that was going to,
mm,
that's something we talked about for a few years about, oh, this is going to
yeah.
drive energy transparency and like energy efficiency in CEA. I just haven't heard folks championing that as like a thing
Me
this
either.
year. Yeah.
I mean, I think when it comes right down to it, is that people are still just figuring out how to do it, right? I mean, until people figure out how to grow XYZ crops in XYZ different structures or buildings, it's going to be really hard to push them towards efficiency, optimization, all these stretch goals, I guess, because we're just still trying to make it a profitable business. And, if it comes down to the fact, coming all the way back full circle to the beginning, that the business case is that so many of these vertical farms and indoor farms just cannot pay their bills, right? Like, maybe they even had a good product, but the energy cost, on top of the labor cost was just too much to bear to be a profitable business. And so if we can make the case that, look, okay, now you figured out how to grow the plant. Now let's talk about how to optimize the systems to keep growing the crop the same as you did before. Not can we grow more, right?
Yeah.
Can we grow the same with less?
Yes. It reminds me of like the Six Sigma or like Kaizen
Hmm.
philosophy in industrial manufacturing of like continuous improvement. It's not continuous expansion all the time. It's continuously kind of chipping away at the waste. And I think that one thing you mentioned about we can grow XYZ crops and XYZ types of systems. I think that thankfully, in some ways, there is this sort of philosophy of growing that inherently has some efficiency to it because of the influence of Dutch growing. So,
Mm.
not every Dutch system is efficient, but some ways of growing in Dutch style greenhouses are efficient. Like the predominance of greenhouse curtains is a great example, right? Not
Yeah.
every US greenhouse uses greenhouse curtains, but pretty much everyone in the Netherlands does. And so I'm seeing that sort of just like that's almost standard practice for the types of businesses that are working with Dutch distributors, um, and those competing with the Dutch distributors. So it's like I think we're
Yeah.
starting to see efficiency almost be influenced by the supply chain, which is what utilities often want. They want to see the market transform without them having to intervene at every single level. If philosophies can naturally be more efficient because of kind of influence from the designers, then even better. So it's not
Yeah.
happening everywhere, but the money has to be on the table at the same time. Some folks can invest in 3 curtains, but not everyone can.
Hey, we recommend 3 curtains if you can afford it. It really
I
helps.
would too. Exactly. That's what I figured I'd mention that. It's like that's the Kaizen goal, right? To continuously
Yeah.
improve. You have this like almost ideal greenhouse, but no one starts with that usually.
Yeah. All right. So, just to kind of bring us to the conclusion here, I'm curious, when you think about the future of CEA, what is your vision of I guess, an energy efficient CEA industry?
Well, I dream of a resilient future. It may not energy efficiency as we defined it earlier is like always the goal is to reduce energy use. Well, in production facilities, the goal is generally more to reduce the amount of energy we use for the amount of production. So it's normalized to production. It's not just 4 million kilowatt hours. Well, it's 4 million kilowatt hours divided by how many grams of cannabis we produced or however many bushels of tomatoes or however many pounds you want to measure things in. Units matter, but it's ultimately, I hope that the resilient future can be a recognition for the amount of things that are being produced by this industry, as well as a continuous improvement in an energy performance. And that could be from on-site energy generation. It can be from combining energy efficiency with electrification when perhaps you were using a fuel like propane. Electrification can work if you are switching from propane to electricity, usually because propane costs so much more than natural gas.
Mm.
But I don't think we can get to this future on rebates alone. Like agricultural grants are a critical source of funding for growers. And I just want to say that we need the USDA. We have to get that support back because existing farms are essentially at a loss. They can't make capital investments without these sorts of grants. You see that in the academia as well. They can't make research investments without these sorts of grants. So I just had to say it. It's like this future can't exist without things like that coming back. But I think that on-site renewables can be a great companion. So my story that I'll tell is just that there are greenhouses out there that are using combined heat and power to generate electricity and to make heat for their greenhouses and to make that CO2. And then they sized it big enough that they're generating enough power to export to the grid, and they're making money from that exported power. And they use solar as well to combine with that combined heat and power. And so that's probably a pretty well-to-do greenhouse. Is that realistic for everybody? No. Like, the future for energy efficient CEA industry is everyone striving to get to that most efficient benchmark that makes sense for them, which for many will not be the perfectly efficient combined with on-site renewables facility. I work with a lot of growers who need to be realistic, and in resiliency plans, some of it's going to be, let's do some of this now and start to save for some of this later. So I hope we have enough time.
Yeah, good point. All right, last question for you. I've asked every single one of my guests this question. So, what is energy?
Who took physics? I did. I asked my partner this. I was like, "What's energy?" And a lot of people define energy with energy, which is really fun.
It is funny, yeah.
But energy is the ability to do work. What's work? Work's a measure of the amount of energy required to move an object. So movement, whether it's an atom or a box or something that's up on a hill, it's really work is the movement of something, and what's doing the moving is the energy. And energy can neither be created or destroyed. We're just converting the potential of something, whether that's a chemical or whether that's, like I mentioned, like a big mountain with the potential energy to roll a ball down the hill. We're going to convert it into some other form, like motion, like the ball down the hill, or electrical energy is mostly what we've been talking about. But with fossil fuels, we're sometimes talking about thermal energy. So fuels and batteries are like the chemical energy, which is a type of potential energy. And when we ignite the fuel, we're transforming the chemical energy into the thermal energy. And we lose some of the energy because of inefficiencies. And that's why we're always talking about efficiency. There's no perfect engine that converts all of the energy into work. If we use that heat to drive an engine, we've converted it into motion. So like when the engine moves the car down the road. But when we're using a battery, we're taking chemical energy and converting it into electricity, which is electrical energy. And when a utility power plant's burning a fuel like natural gas, they're converting the chemical energy into electrical energy and pushing it down the grid, because they're doing what we call, the big transformers. They're like basically producing the energy and then transforming it into the form of electricity we can all use. The last thing I'll say about energy is some sources of energy are finite, like fossil fuels, and some are renewable, like electromagnetic radiation from the sun. Really hard to say that phrase, or kinetic energy from the wind. So the wind will always blow, the sun will always shine. It seems like infinite energy, right? But it still cannot be created or destroyed. We've got this amount of energy to use, and we're trying to convert it into useful work.
That was an amazing explanation, an amazing definition. Honestly, I applaud you. Any physics teacher, I think, would be really impressed with your response. I want to add a couple things to what you said. One is you mentioned, right, like there's no perfect engine. So I'm going to use HVAC because that's, my jam. So we feed electricity to an HVAC unit, and it runs compressors that then create this cold refrigerant that then absorbs the heat from the air in the room and then expands and then, gets compressed again. So for any of you familiar with hot gas reheat, this is one of the ways that we can recover heat when we are doing simultaneous dehumidification and cooling. Is that if we just did the dehumidification part, we're going to deliver air that's really super cold. But we can recover the heat that we absorbed out of the refrigerant from the air But in addition to that, we can recover some of the inefficiencies, some of the friction losses from the operation of the compressors and the condensers and all those components and feed that back into the refrigerant to then have this hot gas reheat coil. So it seems almost counterintuitive, but we can actually recover 100+% of the heat that we absorb during the dehumidification process by recovering the the frictional losses or the work losses of converting the heat to the compressor and back to the refrigerant. So this is one of the reasons why you're starting to see codes and standards say you have to recover heat because there's all this heat available. Why not use it? In fact, let's use what's waste, what we would consider waste that would get dumped outside, and let's put it back in our airstream.
I love that you used an HVAC example, and if people really do care about energy after listening to all of this, I think heat recovery is a great place to learn more about and to look into because it's it's like energy efficiency and energy conservation together. You're sometimes going to
Mm.
have to invest in new equipment to recover the heat, but the ways you recover the heat can continue to be methods of conserving energy. And so I'll just mention that I'm doing a study outside of the CEA industry related to wastewater heat recovery, which I'm curious to see if we'll have applications in the agricultural industry. But if we think about all of the water that goes down our pipes from commercial buildings and residential buildings, it's at a temperature of around 57 to 64 degrees. You may not
Interesting.
like that water. You may not want to touch that water. But if you were able to put it through something that you completely closed loop, you never touch it, you never smell it, you never see it, and you were able to exchange that heat with other loops in your building, it's literally like what you're talking about. It's like, let's stop just wasting this energy. We know it can't be destroyed, but we're just putting it down the drain. Let's take it and actually put it to useful work. So I really appreciate that you brought up HVAC and heat recovery because it's not a sexy topic, but it is a very important part of efficiency.
Yeah, and if you can recover waste heat rather than running an electric toaster to reheat your air, you're going to save a shitload of energy.
Because that's what they are. They are
I
literally
know.
just heating coils. Yep. I love that. I also thought it was cruel of you to put this question at the end because everyone sort of had this conversation about energy with us. And then at the very end, we kind of defined that we were mostly talking about chemical energy getting converted into thermal and
Yeah.
electrical energy. Yeah.
I mean, and for, if you think about it, agriculture, farming, plant production, CEA, whatever version of that is it is that conversion of energy that you were talking about, right? Going from electromagnetic energy, the plant absorbs it, turns it into chemical energy, moves then those photosynthates into the leaves and the flowers and the tomatoes or the fruits, right? The plant parts that then we consume. And so then we consume that as food, which is another metric of energy is calories, which then allows our bodily functions to operate and our cells and our blood and our everything to move around, as well as our legs, right? And we can move from here to there. It all, and then we poop it out, and then maybe we use that, like you
And
were
maybe
saying, right,
we
as a source of thermal energy.
And yeah, and maybe it goes down a drain that has a heat recovery system on it and we actually use it again. And I think that circular energy systems, like circularity, is another place that folks should look into. If you think that there's waste, the best thing to do is connect it to something else and find a way for the next business to use it or the next facility to use it. The research I'm doing on wastewater energy transfer has been really illuminating, learning about how many like district energy and heating and cooling systems there are in the US that could potentially make use of this sort of energy at the multiple buildings level. So
Hmm.
I feel like if agriculture can take anything from that, it's like continue to think about the stuff you're putting down the drain, not just the stuff you're seeing on the utility bill, you know?
Yeah, that's so interesting. I never actually thought about using wastewater as a source of water for a water source heat pump, but now I'm definitely gonna keep that in the back
Yeah,
of
we
my
should talk more about it. We're really curious to see the potential in California and compare it against the potential in Illinois because we're doing studies in both states at the same time. So that's kind of
Yeah.
fun. Yeah.
That's cool. That's cool.
Yeah.
Whose shit stinks more?
Who has more volume and who has more like heating and cooling demand, right?
Can I
It's
just say that California probably has more plant-based energy and Chicago might have, or Illinois might have more, I don't know, hot dog-based energy.
hot dog based energy. Yeah. It's that goes back to our, at the very beginning, energy efficiency is not the sexiest side of things, especially when you are talking about systems like this, you just sort of have to like push through it and be like, do you want to save money or not? Do you
Yeah.
care? Do you really care about the stuff in the mechanical room? Let's be honest. You probably don't after we talk about this. You just want to save money, right? So let's go through that. Yeah.
All right. So Gretchen, I have a few rapid fire questions for you. So, they are meant to be, quick answers, one sentence, yes, no. If you want to expand on anything, you can, but they're just meant to be quick responses. All right. Are you ready?
I am.
All right. Number one, what energizes you?
Making it possible for all types of businesses to be resilient. I really just like seeing businesses survive and thrive, whether it's a restaurant or a grower.
Okay. How much energy is too much energy?
I would have used to say 4 million kilowatt hours. I used to think about buildings like offices. Data centers use too much energy. I think that when you have to have a power plant built for you, you're using too much energy. And that's something that Google's trying to do in New England. So I think that if we're talking about billions of kilowatt hours, we're talking about the scale of which you're paying $100,000 a month on energy. What are you doing? I'm very curious. It's got to be something intense.
Is efficiency always a good thing?
No, efficiency has been used at the expense of marginalized communities for many years. And I think that it is used as a disguise sometimes to penalize certain types of communities, whether that's a certain type of business or a certain type of person. So the word efficiency is not always kind. I think that it should be used thoughtfully.
That is a super profound answer. We're going to have a sidebar on that. If you could be any type of energy, what type would you be?
Sound energy.
Oh, I like that. Yeah, acoustical energy. Love it. Okay, last question. Have you ever knitted anything for your violin?
I should knit a little violin koozie to keep it safe in its case, but no, I've not yet knitted anything for my violin, but you've given me a project idea.
Excellent. All right, that's
That's
it.
fun. Thank you. I love having a surprise questions because, preparing questions, it's always good to have your talking points lined up, but yeah, you never know what you're going to get with things like that.
Awesome. Well, Gretchen, thank you so much for helping me wrap up the energy series. We definitely talked on all the topics and then some. It was fun to get to talk to you about a few things I haven't been able to talk to others about, like electrification, LEED, and the USGBC, just other buildings in general. So, thank you very much for spending time with me to talk about this.
And thank you for inviting me. It feels like an honor to close it out. So I really appreciate all the other folks who joined you as well to help explain energy. I think that it's awesome to see it take off as a more important topic this year. Thank you.
Awesome. Actually, I wanted to make one more note. I meant to mention this at the very beginning because I just realized it before we started, is that you are my 50th interview.
Woo-hoo. Do I have kazoo or cannon or something? I'll have
We
to.
need one. Yeah. I'll ask Dan at
in, yeah,
post-production to add
in
some.
editing, we need fireworks. Thank you.
Yeah. Yeah. So thank you for helping me reach that milestone.
Thank you for having me.
Yeah.
I really do admire the sort of communications work that it takes to have this industry care about stuff. And so thank you for being a platform for that, because not everyone can do it. I'm really thankful for that.
Thank you. Thanks. All right. That's it.
That was awesome. I was like, oh man,